Okay, in session 2, we will discuss about supply chain planning. There is a lot of things in supply chain plannings, and let's go through it one by one. Okay, first of all, I would like to separate the contents of this discussion about supply chain planning into 5 parts. Which include how an supply chain planning is highly related with making an integrated operation planning, and where does the supply chain planning applied in what kind of situations. And then there is a one very often discussed activities which also part of supply chain planning, which is called sales and operation planning. And one of the main part of these activities is that we need to have a good forecasting. So here we will discuss also about what is forecasting in supply chain planning, and how does it what is the characteristics of this forecasting, and what kind of techniques are available to do the forecasting. And actually I plan to also discuss one of the uh, techniques in forecasting which belong to quantitative methods, so-called time series analysis. However, since it's quite a long part of the discussion, so I plan to discuss it in the separate sessions, or we can see it later if somehow it can be managed into this session or not. Okay, on the course outcome, still the same. Course outcome 1 and course outcome 2. Okay, let's start the discussion with how integrated operation planning is normally related topics that we discuss in supply chain planning. So basically, when we do activities in our business, we're not only doing it by ourselves. Even within the organization, there is several departments need to work together, collaborate, coordinates in order to get to able to achieve the purpose of each individual department, or as a um, company. Okay, and in supply chain itself, the same concept is applied when we as a business want to satisfy our customer demand. And in general, we would also like to we will need to coordinate with our suppliers and the suppliers of our supplier, or end tier suppliers, in order to provide the best service that uh, we can to satisfy our customer demands. Of course, these activities need also requires coordinations or collaboration at some points. Okay, so basically supply chains, in order to operate well, or in order to well plan, so we can say it also like that, it requires the coordinations at several process at certain level. And in order to create a well-planned decisions or well-planned operations, basically there are three main drivers that become the keys of effective plannings, which are here, as you can see. Number one is something that we call supply chain feasibility, in which openness of informations in the or in the supply chain would be able to ignite the integrated coordinations. Okay, another thing is that since the resources in supply chain normally limited, so um, in order to plan or making uh, um, decisions, we as a organizations that work together should also simultaneously consider the resource that we have. So, what kind of resource normally limited in the supply chains? It could be the capacity of some machine, for example, the materials requirements, and several constraints also can be a consideration. And another thing is that it's quite related from the second one, which is called resource utilization. So normally it come along with the trade-off in mind, in which normally if we consider a very good service, normally it will be need to to um, sacrifice some other resources. For example, if you want to give the delivery very fast, normally the cost will be quite high, something like that. Okay, now let's see more detail on supply chain planning. So supply chain planning is being discussed increasingly in frequency and scope. So such applications that would be considered as a supply chain planning for nowadays might be different with in the futures. Okay, so but there are, however, some applications that common for most supply chain environment, in which in any type of supply chain in any industry, normally or commonly we will have these four type of plannings which belong to supply chain planning. First, what we call demand planning, in which demand planning normally aims to plan how we could manage the demand, estimates the size, and then the frequency of the future sales of the company. And then the second, based on and also based on the demand plan that we already have, we will have or create production planning, in which the goals of production plan is to determine the productions, the capacity, the working hours and stuff, and also the inventory levels to minimize the total production cost, which also need to consider the limited resources or workforce and equipments that we have in the company. And then third, it will be related to the logistics planning. So the product, the services that created by the company need to coordinate with their logistic functions, including the transportations, the warehouse, and how they will handle the inventory within the firm or and also between the partners and organizations involved in their supply chain. And the fourth one is about inventory or inventory planning, or we can call it inventory deployment, because it's more normally related to how we will allocate and assign the number of inventory in multiple locations, perhaps the in the chains of our supply chain, of course. So SNOP. SNOP is a process that coordinates the demand and the supply and plan across the organization. So it means like in sales and operation plannings, many departments will involve to determines how we're going to what we are going to do based on the the forecast or to coordinate uh, the demands based on the forecast, and then how we will fulfill those demands using our operation plan. Okay, so uh, this process include many things such as information sharing, accountability, and systematically it will create a plan. Okay, it's a plan that will be used as a guideline across the organizations in the future uh, to fulfill their demand. Okay, so the technology later on will utilize something called maybe link spreadsheet that show the coordination between the people in sales, people in the operations, and we will discuss about that later. So basically, in general, SNOP will refer to how we coordinate demand in supply across the organizations. And also it, as you can see in the pictures, it needs to balance the objective, because sales normally will try to, okay, we want to sell as much as possible, and but the operation will try to like, we want to have the cost as minimum as possible. So this coordinated plan is necessary to balance the polar objective between several departments in the supply chain. Okay, this figure illustrates the simplified SNOP process. One of the first components that we have in SNOP process is that there should be a business planning regarding to budget and financial forecast. And this business plan will act as a guideline in terms of activity levels and determine the aggregate volume and resource requirements. Okay, and the second components that necessary for SNOP is there should be a sales plan. A sales plans is normally provided by the marketing divisions, and it will consider unconstrained marketing plan, in which they will only first they will only consider how much order on hand, and then what is the map of the current customer, how will be their point of view based on the new customers and the competitions, something like that. And in other hand, this unconstrained marketing plan will also accompanied by the resource plan. Okay, resource plan in which we will consider how many inventory we already have, what kind of replenishment strategy we will do, what is the capacity constraint of our resources, and many other constraints regarding material, transportation, storage, and so on. And based on these three things combined, we will create something called detailed planning and execution systems, which sometimes have the something called APS, which also will create a production planning, plan scheduling, and how they will schedule the supplier. or sometimes also called aggregate plannings, is the systems which illustrate here in a very simplified way, in which it it we can consider it consists of several plannings along the time periods. Okay, several planning decision along the time period, in which we will have the requirement of some type of products. Okay, and we will have the information requirements. It's can also consider as the demand itself, and then the production capacity of our resources, and then we will create several alternative. uh, Normally will be like, oh, you want to have a stable productions, or you want to try to catch up with the demand. Okay, so this type of strategy commonly known as chase strategy and the stable strategy. Chase and stable strategy. Okay, so as you can see here, it is illustrated that when the productions, when the demand is 200, and um, we know that our production capacity is 300. So we see that there is a contrast between the first strategy, uh, sorry, not stable but level strategy. Okay, normally known as chase and level shown stability in terms of productions. So as you can see here, there is two polar opposite of strategy between this. So the first chase strategy, we will try to produce uh, as needed. Okay, for example, okay, now it's needed 200, and then needed only 200, so we just produce 200. However, for stables or level strategy, they try to produce in a stable manner. Okay, they produce 300, or if somehow it's only used, uh, only 200 is used, so we will have inventory to carry over to the next period. Okay, so as you can see here, along the period 2, when we have demand 200, the first strategy, the chase strategy, they produce only 200. But for the um, level strategy, they keep producing in a stable manner 300. So now they will have another 100 inventory carryover. Yeah? So the drawbacks of this strategy, you may have a lot inventory carryover when the demand is under. However, as you can see later, when the demand is surging somehow here, 600, the first strategy need to do overtime. Okay, so instead they cannot only produce 200, their maximum capacity is 300. So where is the rest coming from? The rest coming from the overtime. So this will be 300 overtime. Meanwhile here, because we have inventory here, 100, 200, 300, so here you just need to still produce 300, and the rest of this 300 that you need to fulfill for 600 demand is coming from where? Coming from the inventory that you carry over. Yeah, so here we have advantage for the level strategy, but here we have disadvantage for the chase strategy. But in the previous period, the advantage in this is on the chase strategy, because they don't have the inventory carryover. As you know, inventory will induce some cost as well. So this is two strategy normally applied in the productions, but there is no right or wrongs, because the demand is very uncertain. So therefore, accurately predicting demand is very important for the this type of plannings. Okay. In order to have a good forecast, one approach is known as collaborative planning, forecasting, and replenishment. So in this approach, or known as CPFR, the forecast planning process and technique is described to be have achieved significant benefit. Okay, so it's reported have significant benefit in providing superior and providing superior supply chain performance. Therefore, we this book somehow discuss about it. So in in easy explanation, CPFR is a process which initiated by consumer products industry. Okay, so normally fast moving good customer good industry. So to cheap because they sell a lot of SKU products, so they need to have such coordination in somewhat the replenishment of the products at the perhaps the retailer side of it, because they are the one that are facing the end customer, will be done or coordinated by the upstream side of their supply chain. Okay, so the demand predictions is being done together, and then collaboratively do the um, replenishment, do the planning, do the forecastings along with along with the several party in their supply chains in order to have a better prediction, um, so that the fulfillment of the demands will be done more precisely. Okay, of course, for doing that, the collaborations need to be very strong, including they need to also use um, several information settings at several detailed level. Okay, now that you see how important the forecastings in the supply chain plannings, we would like to discuss further on the forecasting concept itself. Okay, so forecasting itself is, as you can see, the application is so many in terms of the supply chain planning. Forecasting itself is a method to to predict some variables that might happen in the future. And methods to do forecastings, we can classify it into two, which belong to quantitative methods and also qualitative methods or subjective methods. Okay. About quantitative methods itself, it can also classified further into causal approaches and then time series models. Okay. Um, for the first section of this session, we will not discuss in very much detail about all of these methods. However, we will discuss the concept first. Okay, now let's see the subjective or qualitative forecast method. So basically, subjective and qualitative forecast uh, is the one that you often see using expert subjective judgment, or sometimes also called intuitions, to provide their or to produce their quantitative estimates about something in the future. For example, when we ask the boss, normally they will give you some hints about, oh, the boss might think, or the director or the CEO might give you like a direction. Oh, the demand of these products may be like this, like this, like this, because they know the characteristics of the customers, because they already working on the business for several years, for example. These are one of the example of subjective judgment. Um, for this type of approach, historical data may not be normally will not it's suitable when the historical data is not available uh, uh, or has little relevance to the forecast. Okay, so for example, for a new products, sometimes new products doesn't have their historical data, or there is no similarity with the previous product. So this for this type of forecast this type of variables, you need to uh, allow at some degree the type of subjective or qualitative forecasting method. Okay, and well, the nature of subjective forecasting approach is that it is very difficult to validate the accuracy compared to the standardized method. And yeah, this one is the example, right? New products, and it is also suitable for medium to long range forecasts. Okay, further um, there is one particular method, so-called Delphi method, that we can also utilize to um, uh, to have a proper structure of qualitative forecasting. Okay, so yeah, basically for qualitative forecasting, as I mentioned earlier, will involve expert judgment, right? But how you create a procedure that will allow this expert provide that judgment in a more systematic way. So Delphi method, one of the approach that you can use. So basically it's an iterative procedure where forecasts are collected from number of experts. So in the case of that you have only one expert, you can also do iterative procedure. However, the procedure will be not as long as the many number of experts. But let's say you have number of experts more than one. So in order to get their judgment more systematically, very systematic way, first at the beginning, every expert will be asked regarding their judgment about some forecasted variables, and to systematically reduce their judgment into one or a consensus of forecast, so some forecast that everyone agree on. During the next iterations, a statistical summary, so summary regarding the forecast, for example, among these experts, the most in average, everyone forecasting this amount, and with a standard deviation like this and something like that. Okay, so it normally presented anonymously to have a more objective judgment. The forecasts are then made uh, so this statistics is based on the forecast made by the expert in the previous iterations, and then later on in the next iterations, those experts are then asked again if they want to revise their forecast based on the new information provided to them. So basically this will be done in several iterations, with the goal of this Delphi method is to generate a consensus for this group of experts to agree on some numbers of the forecast. Okay, so if somehow it doesn't meet the consensus at one number, normally final forecast is generated by averaging the forecast from the individual experts. Okay, now we talk about the quantitative uh, forecasting method. So basically, quantitative or a more objective forecasting method has two type, right? First is the uh, time series analysis, in which the forecasting method based on time series analysis is a forecasting method that based on the assumption, a fundamental assumption that the future that estimate will be based on the prior or historical value of the same variable. For example, if you want to forecast demand, the demand of in the future can be forecasted or can be estimated by the demand in the past, the number of demand in the past, something like that. So this implies that historical pattern uh, will exhibit the variable to be forecasted. Okay, so you can forecast the future based on the historical pattern. Okay, so well, it's based on this statement. It means that it is necessary to have historical data, and the only independent variables. Okay, so for a time series, the only variables that being used to forecast those future or or we can call it in the forecasted models is the data of the time series itself or the historical data itself. And it means that the future value of the variable will be equals to the patterns regarding to the data that we want to predict, plus, okay, because we are not very sure it will be equals to the past pattern, so plus some random component. So the goal is to predict the pattern as good as possible, because this random component we don't really sure how much is it gonna be. So it is assumed that the expected value of the normally time series analysis will assume the expected value of uh, the random component itself will be normally distributed. Okay, uh, normally distributed, and then the expected value will be equal to 0. Okay, because yeah, we assume that it will be very less. Okay, and then the random component itself is have variant this sigma square. Okay, and is this represent this formulation represent what we have just discussed, that this prediction will be equal the forecasted pattern plus the random variable, and the random variable itself is assumed normally distributed with expected value or means equal to 0, and the standard deviation is equal to uh, sigma square. Okay, where normally time series analysis or forecasting method are used. So time series forecasting method are mostly used to forecast variables in a short or intermediate terms, because for longer terms normally we need to have some complex analysis, and it's normally involve expert judgment, which will belong to qualitative approach, or sometimes we can also combine with qualitative and quantitative. It belongs to mixed methods. And a generic forecast models can be represented by this formula, where the forecast at the time t plus 1 will be equals to sum of the past combination of past observation multiplied by the weight, which will be assigned based on each forecasting models. Okay, and time series models can also divided further into static model and adaptive models. The difference between these static models or methods is based on the model parameters regarding the offset, the trend, and the seasonality factors. Okay, for we will discuss it more later, but some things that we can say is that the model parameters on the statistic forecast will only estimate it based on the historical values. Then the same values are used to compute all the future forecasts. Okay, so it means that this data regarding um, offset, trend, and seasonality were not predicted again in the future, or will not estimated again the parameter regarding that for the statics forecasting methods. Okay, one example of static forecasting method is the average techniques or regression techniques. Meanwhile, for an adaptive forecasting methods, these parameters is updated after each demand observation are known. Okay, so whenever we have a new demand observations, okay, the parameters of the forecasting model were updated. And an example of this is that the moving average and several variants of exponential smoothing. Now that I have mentioned several forecasting methods regarding time series, but I will not discuss in more detail yet about how it is calculated, what kind of formula being used. But now let's just see one step further regarding the weakness of time series analysis. The time series exists where the values forecast availables are related or somehow correlated from period to periods. It means what? It means that whenever you have data, you predict data from the past data. It's most likely the future data will be correlated with the past data, right? So in this case, the data is said to be autocorrelated. The data in the formula, so the approach that we discussed earlier will no longer valid for such time series, okay? And most often is like that. However, therefore, this researcher here, develop a group of method or several methods that can handle autocorrelated data. So, which is right now called autoregressive integrated moving average or ARIMA methods. And later on, there is an extension about the ARIMA methods. You can find another later. But this advanced forecasting method for a time series that developed by Box and Jensen is very powerful to provide a forecasting that has an extensive understanding of the underlying process. But however, it is recommended to have much more data than the other forecasting technique based on time series analysis. At least 72 observation is needed to start the forecasting the futures. Okay. But of course, however, the forecasting the factors that can be used to forecast future data is not only the past data itself. There might be another variables that can be used to predict those variables that we want to predict. Then A second major category of forecasting models that belong to quantitative models is called causal model. The basic assumption is like this. Causal model assume that the future value of a forecasted variables can be expressed in a mathematical function of the known current value and of a set of different variables. For example, if you want to predict demand, it can be predicted, of course, by the previous demand, right? But another variable might also available to predict that one. Let's say, oh, the marketing budget, yeah, that might also predict the demand. So these are the assumption of causal forecasting methods. Okay, so the known variables in the causal models are called the leading variables since they occur before the lead or the forecasted variable indicate the behavior of forecasted variables, or sometimes called independent variables. And the causal relationship can be expressed this way. Okay. Okay, we will discuss also again later several forecasting methods. However, now let's see first how can we measure one method is good or not good. Okay. In other way, how can we judge the quality of the result of one forecasting method compared to another? Okay, one indicators for measure the quality of forecasting method is to see the forecast error. Okay, the forecast error, okay, as represented in this formula, is the residual difference between the observed value and the forecasted value. So this is the real data available, and then this is the forecasted data. The difference between this, we can call it the forecast error. And based on this forecast error, there are several common measurement that is available to show how the forecast quality of a certain methods. Okay, first one is the means of error. Okay, so total number of error divided by number of observation, and then there is a mean average deviation. So error can be positive and negative. So it's when we take the absolute value, you get the deviation value in positive way, and then you divide by number of observations. Another one is mean square error. This one, the error is being squared, and then later on summation of it divided by number of observation. This will show sometimes being used for also for forecasting error. And then root of mean square error. So the value of this, you calculate the root of it, and then you get the RMSE. And all of this is represent in the error units. Another approach that is easier to understand for some business people is to show the mean average percentage error. So this will be in terms of percent, as you know that 100% is the most and 0% is the minimum. So this can give some easier understanding for some people that doesn't really know this unit of measurement. Okay, next is we talk about confidence interval. The forecasting value f that we show earlier is refer to a single numerical value, or we can call this one point estimate or point forecast. But sometimes yeah, it is most often that a forecast will fall below or fall for under or for upper of the point estimations. So sometimes it is more useful to replace the point estimates or point forecast into an interval, because if you know that if the interval of the estimation is large, mean that it is difficult to to very rely on this forecasting result. However, is the forecast result, the interval of this forecast result is not so large, so we can focus on those interval only, right? So um, an interval for which we can assert the specific degree of certainty, yeah, certainty that contains the expected value or the forecast variable is called the confidence interval. Typically, it claims to be made of probability 1 minus alpha. Okay, so with a probability of let's say if you have the alpha 0.05, so the probability of 95%, the expected value will fall under this range, in which the calculation of this one, c minus c of alpha divided by 2, is derived from the normal distribution tables. Okay, next is the regarding to the um, forecast that we already made. Okay, it is often that we need to monitor it carefully to verify the models, if the models that we use to forecast is become invalid or not. Yeah, there is here we were introduced by two way to monitor the forecast methods. First, so-called bias. The bias at time or period t will be equals to the accumulations of the error from every previous periods. So because we assume that the error will be close to zero, so as this error number is getting larger and larger, so it means that there is something wrong. If this number is always become larger and larger, there is something wrong with our forecasting methods. And then another thing is called tracking signals, in which we have the bias divided by the mean average deviation of that particular periods. Okay, so this is the basic about forecasting. I hope to be able to provide to you more details about the time series forecasting methods. However, if it is not, please go to the book that we use for this, the main reference for this slide, and you can see the chapter related to the time series forecasting methods. So thank you very much for listening.